Alright, y'all. So I wasn't going to do a video on this because I was really hoping to wrap up this Tech 2230 scope in just one last video. You know, I basically had the whole thing repaired, some of that not shown, and I was just going to quickly go over some of those other repairs I had to do, and then just go right into the calibration adjustments or performance checks, and call it a day. But as I was in the process of putting this thing back together, I made a really stupid mistake and potentially shorted something out on the vector generator board. Excuse me. And so now I did post a 30-second video that will be up as well that kind of shows this a little bit better. But now any of the readout displays, or when the unit is in storage mode and you're looking at a waveform, it basically sandwiches the whole display. You see, because this is actually, if you remember, this is basically that vector generator calibration screen that was stuck on the unit. Now I put it in this mode to do some of the to check some of the representative waveforms in the schematic. You have to put it in this to check those. And normally that vector generator display covers the whole screen, and you can clearly see it's sandwiched right in the middle. And so that is what this new fault symptom is. Now, as I was saying, the vector generator board is responsible for generating the vectors, any of the vector displays. So that includes the readout, and that also includes the waveform and your signal when the unit is in storage mode. So if you in either of those, it'll sandwich the readout on the bottom and the top, and if you have the waveform in the center, it looks great, but if I bring it down a bit, it'll sandwich it. And again, if you look at that 30-second video I posted, it shows a better example of it. But so I figured, this being an interesting fault, why don't we do a video on troubleshooting it? Okay, so right now I'm just looking at the vector generator schematic and the representative waveforms. So right now this is 129 and 130. So basically those are the outputs of these op amps, which the inputs to these op amps are X Vec, which you see there, and Y Vec. And those signals come directly from the DACs, the X DAC and the Y DAC, which is taking information from the display controller. So that's where we're starting. All right, and I have both of those spots probed, and it's looking good. That's pretty much what you want to see. Looks pretty similar to the representative waveform given in the service manual. So I'm just going to go through and check each one of these and see where things start to differ. Now, I actually did post in the EEV blog about this originally, and at first I was not getting these waveforms, and the reason why is I did not read this fine print here. As I was saying, to get these waveforms you need to have the calibration box opened, and I didn't. And so I thought initially that right off the bat there was an issue. And I started getting really worried, because if the outputs of these op amps are already starting to show problems, well, that could mean that the issue is somewhere on the storage board. It could be the display controller itself, and it didn't make sense to me, because if you put as I was saying, if you put the readout in the center the waveform in the center, it looks fine. So that means that it's, you know, the display controller is working properly. It's something with, there's something else going on here. And sure enough, that looks good. So it's got to be, I'm thinking, somewhere on the vector generator board itself. Again, that I believe is where a potential short occurred when it was that board was touching the input output board, and so I think that's what happened. But you know, yeah. So I actually was doing a lot more troubleshooting already, and one thing I did find, if you look at yeah, so you see U6. Let me grab a pencil real quick. Oh, here we go. There's a good pointer right here. Yeah, so you can see here where it says 1.98 volts. These two transistors, which are part of a 5 transistor array, this CA3046. Yeah, so I measured these two at the collector of these pins 11 and 8 of these two transistors, which then move on to which are labeled DV out and UV out. Well, this goes back to the main board, where it meets up with the vertical deflection multiplexer for the CRT. So that's not measuring 2 volts. I measured 7 volts. Alright, and both of them should probably be about the same, although it only labels this one. Yeah. So there could potentially be an issue with this transistor array, but you know, I just wanted to point that out first. We're going to move down through each of these waveforms, starting here, which is where we're at now. We're just going to kind of move through this circuit through the vector generator, and then the vertical vector amplifier. Now it seems that the vertical vector generator and or amplifier are the only thing being affected right now, but just for comparison, we'll be also probing the horizontal vector generator as well, and vertical horizontal vector amplifier. Alright, so we've already done 129 and 130. So I think next we'll do 131 and 132, which is probing this sample hold integrator, both of them for vertical and horizontal, U6305 and U6306. So let's get started on that. Alright, so now we are probing, as I said, this is 131 and 132, which is basically just pins 14 on each of these sample hold integrators, U6305 and U6306. Now, this signal is actually coming from the vector sample line here, okay? And so, yeah, it comes through this resistor R6330, and it then goes to U6306, which is the horizontal vector sample hold integrator, and then U6305 up here, okay? And this is the waveform, and that looks pretty similar. So this is a good indication that the display controller is working, at least in that regard. So yeah, we can move on to the next waveforms. Alright, so now we're on to 133. There's the sample waveform in the service manual. And so 133 is basically this vector dot signal right here. And this again is coming from the display controller, which is an ASIC. And yeah, so this is actually R6202. This is on the input-output board. So I'm actually probing here. It's just the easiest spot for me to attach my probe. But you can see this signal goes to U6301 and also C, and then U6301A. And these are this is a multiplexer, okay? And I think basically this can switch from when you're in vector mode or dot mode for the, well, no, this is for the vertical and then the horizontal, I'm sorry. And then another part of the multiplexer is this guy right here, which takes a signal from plot enable. So when you enable the plotter, I think this guy gets activated, and the signal for the multiplexers here are disabled. So again, this is just monitor. Well, I forgot to show you. This is the, again, looking exactly like the representative waveform in the service manual. But again, this is more so checking the display controller and not so much the circuitry on the vector generator board. But we can move on from there. Alright, so now we're on to 134 and 135 and looking at the schematic. So we're still in the vector generators section of the circuit, and so this is 134 on the output of this LF356, which is part of the vertical vector generator, and then 135 is right here on the output of this LF356 for the horizontal vertical generator. This is what we have on the scope. It looks a little bit different than you know, what is represented in the service manual. Both of them look a little different, but I don't know if that's something to be concerned about, if it's just that, you know, again, because of the fact that it's sandwiched like that. I don't think this is due to the an issue with the display controller or anything like that. But yep, let's move on to the next waveforms, which I believe now are in the vector amplifier, which is getting closer to what I think could be the issue. Alright, so we moved on to 138 and 139 representative waveforms from the service manual, and this is for the horizontal vector amplifiers. So 138 and 139 are both at the emitter of U6402C, U6402D, and that's what we have on the scope, which looks fairly similar to what's in the service manual. So now take a look at the vertical vector amp as well. Alright, now on to the vertical vector amplifier, and so here's the representative waveform in the service manual, 136 and 137. There's 136 and 137. Again, just like the horizontal, you've got 136 on the emitter of U6401D. 137 is the emitter of U6401C. Now, here we got something a bit different. Okay, so definitely not what is being shown in the service manual. So again, this is what I had mentioned earlier, that this 5 transistor array, this CA3046, which is U6401, might be faulty. And I did order one of these, don't have it on hand yet, but I mean, I'm going to replace it anyway. I was thinking it's just 5 NPN transistors. Why not just take 5 general NPN transistors and put it in and see if it makes a difference? I think I'm going to give that a try next and see what happens. Okay, I just wanted to check one more waveform, and this is 140, which is the H position display controller signal. So that comes from the display controller right there, and it makes its way. That's where 140 is, this transistor from U6303A, which shunts the signal. And so it's looking good there. That's the last one I wanted to check. These other ones are for like U41, 141, I'm sorry, and 142, 143. Those are for the plot drive circuitry, which I'm not too concerned about. So that's for the XY plotter. So again, I'm going to move on to removing that U6401 and replacing it with some discrete transistors and see what happens. Alright, so before I get started here with replacing this CA3046 with some discrete components, I just wanted to show you guys the datasheet. So this is it. General purpose NPN transistor array. The CA3046 consists of 5 general purpose silicon NPN transistors. And then they give you basically the schematic for the device right here. Okay? And so you can see that you can see them right here. You can see that 2 of them are a differentially matched pair. So, you know, it would likely be a problem to keep what I'm about to do in this unit long term, because these transistors are matched, and they even give a spec for how closely they're matched, I believe. Oh, yep, it's up here. Yeah, so, you know, you could have some adverse effects by keeping them, because I'm just picking 5 discrete transistors from my component inventory, which I'm going to use some A05s, and yeah, they're not matched by any means. I don't even know if they're from the same lot. So, you know, but this should, if this is the issue, it should at least resolve the fault symptom we're seeing. I did order one of these, it's just not here yet, so, you know, I just wanted to make that comment that I wouldn't suggest doing this long-term as a long-term fix. But yeah, let's get started. Let's remove the original CA3046 and, you know, we'll install these transistors and see what happens. Alright, so I've got the CA3046 removed from the vector generator board, and we're just going to do a test of the transistors with a, just using the diode test function on my meter. Now, again, if I've showed this before in a few other videos, but to do this test of a BJT with your DMM, it's pretty straightforward, especially if you have the diode test function. For an NPN transistor, what you're going to do is connect the positive lead to the base and then the negative lead to the collector, and you should see basically what you would see if you test a general purpose diode, roughly about 0.6, 0.7 volts. To do a PNP, you just reverse the lead. So base would be the negative lead, positive would be the collector. Uh, yeah. So that's what we're going to do here. These are all NPN transistors. So I'm also got my ESD strap um, on my wrist just so I don't short out this device any further than it might be already to skew any results. But yeah, so we're going to start with the differential pair. So let me just double check the data sheet. Okay, so the base is pin 2, collector is pin 1. All right. Sorry if you guys can't see everything I'm doing here, but this should just give you an idea. Okay, and this is definitely not what you want to see. So there's clearly something going wrong with the first transistor. We should be seeing about 0.7 volts here. And let's reverse the leads just to see. Okay. All right, well, that's what you would see. That's what you should see. But clearly, that's not the voltage drop you would expect for the first transistor. Let's do the second transistor in the differential pair, which is the base is 4 and the collector is 5. So let's do that. Connect the positive lead to base pin number 4, negative to pin number 5, and see what we get. Wow. And so that is reading open, which is definitely not what you should see. Let's just reverse the leads to see what we get. And yeah, both of them are open. So, I mean, in both directions. So, definitely a problem with that transistor as well. So it looks like so far the differential pair of transistors, there's definitely something wrong with them, which could explains why we aren't getting the waveforms that we should be getting, and potentially why the output of this vertical vector amp is, we're measuring 7 volts instead of the 1.98 that the service manual says we should be getting. So let's, just for comparison, we'll check another transistor in this IC. The next one is Q3, which is the base is pin 6, and the emitter is, I'm sorry, the collector is pin 8. So let's do that. So positive lead is on pin 6, negative lead is on pin 8. Okay, now see, that's what you should be getting. All right, and we can reverse the leads, and it should be reading open circuit. So let's just do that real quick. Yep. So that's what you should get for a good transistor. I'm not going to test all the other ones on this video, but just for time purposes, but I think we found our culprit for what's going wrong with this vector generator board. So let's move on. Let's put in the 5 discrete transistors and see what happens. All right, so I've soldered in my 5 discrete transistors where that CA3046 would go. Not the neatest setup, and the reason for that being is that, you know, if you look at the IC, the pins for each of the legs for each of the transistors don't line up very nicely, you know, so I had to bend some leads, twist some leads, and that's why it looks the way it does. But for troubleshooting purposes, this should just work fine. So let's fire up the scope and see what happens. Okay, so let's power it on, see what happens. Come on. Oh, there you go. Check that out. It's fixed. Yep. So you can see how it says the readout at the top there clearly. Readout at the bottom is nice and clear. Now, if the fault was still there, you wouldn't be able to see the readout at the top and the readout at the bottom. They would be sandwiched. It would just look like a line on the top and the bottom, and it's not. So this has been fixed just by adding those, removing that faulty CA3046 and putting in 5 discrete transistors. So this is fantastic. I am ecstatic because I was just really kicking myself that I had prepared this whole thing. And again, I'm going to do one more video after this one because there's a lot that happened in between this video and the last one I did. Some additional repairs I had to do to get this thing fully operational. And with this last thing, we can move on now after I put the thing back together and not break it this time. And we can start the calibration procedure, or at least do the performance checks. But yeah, this is fantastic. So, you know, there you go. We can wrap this up now. I hope you guys found that interesting or helpful, and I'll catch you guys next time. Again, I'll be doing another video on this guy. Just keep an eye out for it. All right.